We are very grateful to have our distinguished speaker today, Professor Terri Pigott from the School of Public Health and the College of Education at Georgia State University. With a PhD in measurement, evaluation, and statistical analysis from the University of Chicago, she was formerly professor and associate provost for research at Loyola University Chicago. Her research focuses on methods for meta-analysis, including statistical power, missing data, and individual participant meta-analysis. She's the founding chair of the American Educational Research Association's Special Interest Group for Systematic Review and Meta-Analysis. Professor Pigott will cover topics including what kind of research questions that can be addressed by meta-analysis, new meta-analysis methods used in social and behavioral sciences, and examples of meta-analysis used in business and management. So we are in for a real treat today. Terri, please welcome and please take over.
Thank you very much, Leanne. Well, here, let me share my screen. So thank you all for being here. And thanks again, Leanne, for that lovely introduction. So today, what I hope to do with you is to give you an overview of meta-analysis and its purpose, to talk a little bit about examples of meta-analyses applied to issues in business and management, outline the steps of included in a meta-analysis, and then talk a little bit about the innovations that are occurring as we speak in meta-analysis methods that would really be applicable to business and management. So let me start by talking about what is meta-analysis. So meta-analysis refers to statistical methods that are used to synthesize the quantitative results from a set of studies. And we typically use meta-analysis in other contexts, but it's typically used in the context of a systematic review to make generalizations about the effects in a literature. So for the purpose of this presentation, I'm going to assume that we're conducting a meta-analysis in the context of a systematic review. And I define systematic review as a method that comprehensively and transparently identifies studies on a given issue in order to synthesize the findings in these studies. Okay, so you might ask, how does meta-analysis contribute to our knowledge in a given topic? Well, in management and business, and in education, and in crime and justice, and in medicine, and all the social sciences, there is a movement for evidence-based decision-making. And so meta-analysis and systematic review can contribute to this movement for evidence-based decision-making by providing comprehensive and replicable methods for synthesizing what we know and what we don't know in a given area. And that way we can base our decisions on what we know, and then we can plan new studies to gather evidence about the gaps in our understanding. So let's start talking about what questions meta-analysis can address in any area, really. And there are sort of, if we think, and we're going to be focusing more today about questions that we might address in business and in the business and management literature. But there are sort of two groups of questions that are most prevalent or that we can address in a meta-analysis. And the first set of questions has to do with effectiveness of interventions. So this is probably one of the more common applications of meta-analysis in, say, medicine. We might ask a question, is a particular intervention or treatment effective as noted in a set of studies? So we might have a set of studies on a given intervention, and we might want to ask, does the intervention seem to be effective? And then we might also ask, and this is also an important question to ask, how does that effectiveness of the intervention vary across those studies? So that's the first sort of one of the main questions we might address in a meta-analysis. A second question that's sort of related to the effectiveness of intervention questions is about group differences. So we might not be interested exactly in the effectiveness of intervention, we might want to know if two different groups differ on some characteristic. So for example, a classic example of this might be, all the studies that have been done in sex and gender differences in leadership. So those studies are not necessarily about interventions, but they are comparing two different groups on some characteristic. And then another, what I would say probably really common application of meta-analysis in businesses and management would be questions about associations among constructs. We might really be interested not in interventions and not in group differences, but how do two constructs or measures relate to one another? And then again, a related question to that is, how does that relationship vary across studies? So let me give you a couple of examples from my own research, and then we'll go into some examples that are more specific to business and management issues. So in my own work, I've been involved, had the opportunity to be involved in a number of meta-analyses related to the question of intervention effectiveness. One of these is a systematic review that was looking at the effectiveness of school-based interventions to reduce dating and sexual violence. So there we're looking at all the studies that look at these kinds of interventions that are trying to reduce dating and sexual violence in teenagers. Then a second one that I just worked on with colleagues was looking at the effectiveness of accommodation-based programs for individuals experiencing homelessness. So how effective is it to give homeless people accommodations, and and looking at the outcomes of those sets of studies that look at accommodation-based programs. And I've just recently finished a review with a College of Education Human Development faculty member, John T. Myers, looking at the effectiveness of interventions that improve the word problem solving skills of students with math difficulties. So here are just some examples of systematic reviews and meta-analyses that are looking at the effectiveness of interventions. I've also worked on a couple of meta-analyses that are really looking at associations between constructs. So recently I've worked with a SMU faculty member, Priscilla Liu, on looking at the relationships between big five personality domains and alcohol use or misuse. So how related are measures of the big five personality domains to alcohol use or misuse? And also currently working on one that's looking at the relationship between children's spatial skills and their math skills, with a faculty member at the University of California, Irvine, Kanari Atit, and someone from the University of Limerick, Jason Power. So again, both of these examples are examples of meta-analyses that are looking at relationships between two constructs, not at necessarily the effectiveness of interventions. And other kinds of meta-analysis research questions, less common in the social sciences, but also I wanted to mention. One might be, for example, about prevalence. We might be interested in estimating the prevalence of some condition or phenomenon as measured in studies across the literature. So one example might be trying to estimate the incidence rate of something like domestic violence in low and middle income countries. And this is a question that is common in public health, trying to estimate the prevalence of some condition or phenomenon. And then another, I just thought I'd mention this one here, another common meta-analysis research question that actually occurs more in medicine are looking at screening and diagnostic tests, looking at the effectiveness of particular kinds of screening and diagnostic tests for identifying a condition. And I thought I'd just, this popped into my email recently because there was one that's looking at the effectiveness of antibody tests for identification of current and past infection with SARS-CoV-2. So these are both other questions that we might use meta-analysis for that are less common in the social and behavioral sciences. But let's get back to why we are all here, and let's look at examples in the business and management literature. So my colleagues at the Center for Evidence-Based Management sent me a few resources to help me prepare for this talk. And one of them was a document on that they've produced on rapid evidence assessment of the scientific literature on attributes of effective teams and interventions increasing team effectiveness. So we're going to look more deeply at a couple of examples from this rapid evidence assessment in my talk today. So going back to uh, the main questions that meta-analysis can address, one of the first questions that we might think about, again, is this effectiveness question. How effective is an intervention, and how does the effectiveness of that intervention vary across studies? So from that rapid evidence assessment that I got from my colleagues, there was one meta-analysis here that looks at the direct effect of team training on team outcomes. And so we'll be looking a little bit more deeply at the results of this particular meta-analysis, but this is an example of a meta-analysis that might look at a specific intervention, in this case, team training, and then outcomes related to team training. And they have a whole set of outcomes here that cover effective, cognitive, and teamwork skills and so forth. So that's an example of that, of a meta-analysis in the business and management literature that might be focused on the effectiveness of some intervention. So a second example is that example about looking at group differences. So we might be interested in if there in differences between two groups on some characteristic, and then want to understand if the studies vary in their estimates of this difference. And this is a study from 2003 by Alice Eagley and colleagues that's looking at transformational, transactional, and laissez-faire leadership styles, comparing women and men. So again, this is not a meta-analysis that's looking at interventions. It's really looking at those group differences. And so there might be meta-analysis can also be used in a meta-analysis, in a context where we're really interested in understanding the differences between two groups. And then the last example I wanted to show you was an example of a meta-analysis that is interested in these associations among constructs. So how do two constructs relate to one another? And is the strength of the association between these two constructs related to, is it vary across studies? Is it related to to characteristics of studies? And in this study by Belkundi and Harrison, they're really looking at characteristics of social network structures, of members and leaders' social network structures, and how that relates to the effectiveness of teams. So here's an example of a meta-analysis that's not interested in interventions. They're really interested in understanding how characteristics of social network structures, that include members and leaders, how those are related to team effectiveness. Okay, and so we'll be looking a little bit more at details about this particular meta-analysis in a minute as well. So, so I wanted to move on to now moving from talking about the kinds of questions we might address in a meta-analysis to begin now to talk about the steps for conducting a meta-analysis. And as I said before, I'm going to assume that we're conducting a meta-analysis within the context of a systematic review. And so just to review, systematic reviews include a comprehensive and replicable search of the literature. So if we're going to use a meta-analysis to quantitatively summarize sets of studies, I'm going to assume in this that we've already gone through and done a comprehensive and replicable search of the literature to identify all the studies in a given topic. And then we also use replicable and transparent methods for screening the studies that will be eligible for the review. And if people are interested in, in some of these methods, I can provide resources later, but we're not going to be talking about that here. And then after we've identified those eligible studies for the review, systematic reviews then are going to go into those studies that are eligible and extract and code information from those studies to use in the analysis of study results. And I'm going to spend a little bit of time on this part of a systematic review because it's a critical part for a meta-analysis. Because what we want from each study then, we want to extract from each study information about study characteristics, like the participants in the study, things about the interventions, if that's important or applicable, things about the study design, things about the outcomes, information about the settings. And then we're also going to want to extract from each study a measure of that study's effect, whether that's a measure of the effectiveness of the intervention or the association between two constructs. And we want to extract this information both to describe the kinds of studies we have included so that we can give our readers, after we've done this, give our readers a sense of what is the landscape, what is the, what are the nature of the studies in a given context. But more importantly, we're also coding because we want information to help us understand why studies might differ in their results and their effects. So that's why this, I'm spending a little bit of time on data extraction and coding in this presentation because it's so critical to the kind of meta-analysis that we can do. And I wanted to give an example from the Balkundi review. This is the one that's looking at characteristics of the team network structure and team performance. And so this is a figure from the Balkundi article that's looking at, it's giving a theoretical framework for the meta-analysis. So if we just look here at this link here between the team network structure and the team performance, what we see here is that what they're hypothesizing is that whatever the relationship is between team network structure and team performance, it may be related to, for example, how familiar the team members are with each other. That the strength of that relationship between the team network structure and team performance may be moderated by how familiar the team members are among each other. And so this is an example of a theory that might lead us to make sure that when we're coding our studies, we're going to code something about the familiarity among the team members within each of the studies. Another example that we're going to dig into from our example meta-analyses is from the DELISE study. If you to recall, this study is looking at the effectiveness of team training and team effectiveness. And one of the things they hypothesized was that the kind of sample used in the study may relate to or may moderate how effective team training is. And so one of the things that they hypothesized in the study is that military samples may experience the team training, may have different effectiveness from the team training than civilian samples. So here's another example of something that we would, want to be very careful to code in our individual studies because it might help us understand why the effectiveness of team training differs across the studies. Okay, so my last couple notes about data extraction and coding. So data extraction coding is arguably the most resource intensive part of a systematic review and meta-analysis, but it's critical to what we can do then in the meta-analysis part of a systematic review. And these study characteristics that you code should reflect important issues in the field and also relate directly to hypotheses about why study results might vary in your given context. Okay, so let's move on then from talking about coding important issues of the studies that we might use in a meta-analysis to coding and extracting effect sizes. So in a meta-analysis, we also, the key piece is that we're extracting an effect size from each study. So this is a measure of the studies, and this measure of the study's results, this effect size, is going to be the outcome for the meta-analysis. And effect sizes, the best way to think about effect sizes is that they're standardized measures that we get from every study. And that allows us to compare across studies, even when studies don't use the same measures. So in the social and behavioral sciences, in in business and management, in the areas in which we are most interested, there are few universally agreed upon measures. We're not in the area of medicine where we have a measure like blood pressure that everyone uses and means something. In the social and behavioral sciences, we may use multiple measures to measure the same construct. And so in order to compare across studies, we're going to need some kind of standardized measure to do that. And that's what effect sizes are. So there are two common effect sizes that are typical in that relate to the kinds of questions that we're asking, that I've posed in this particular presentation. And they are the standardized mean difference and the correlation. So we use the standardized mean difference when we're interested in those effectiveness questions, when we're asking about whether an intervention is effective, when we're asking whether or not the experimental group that got the intervention is performing better than a control group. We also use the standardized mean difference when we're thinking about group difference questions. So we're going to, Eagley et al. Used the standardized mean difference in looking at the difference between women and men on measures of leadership, such as transformational transactional leadership. And so we're going to use something called the standardized mean difference for those kinds of studies. For the association studies, like our example about characteristics of the team network and the team effectiveness, we're going to use correlations. And so we use correlations when we're looking at association questions in meta-analysis. So I know there are some formulas on the screen. You'll never be asked about them. I put them there just so I can talk through them with you and I can point out a few things. So this is what the standardized mean difference is. This is the standardized mean difference here on the left-hand side of your screen. And you can see that in the numerator, it's the difference between two means. And so we can imagine that in the study on the effectiveness of team training, this would be the difference between the experimental group and the control group. In the Eagley study on the sex gender differences in leadership style, this would be the difference between men and women. And in the bottom then is pooled standard deviation. So the standardized mean difference is really looking at the difference between two groups in standard deviation units. Okay. And I just wanted to alert you to the fact that the standard error of the standardized mean difference is this horrifying looking equation on the right here. But note that what's involved in it is the sample size. So the sample size is involved in the standard error of the standardized mean difference. And we're going to come back to that point in a minute. Okay, so the second kind of effect size that we're going to be looking at, the one that's associated that's for associational studies, is really that just the correlation. So when we're looking at a meta-analysis focused on association, we're going to extract the correlation R from each study. The only complication in meta-analysis is that because the correlation is not normally distributed, we tend to use a transformation of the correlation in the analysis called Fisher-Z. It's not important that you know what that is. You can see that the correlation, the R, is involved in that formula. But again, look at the standard error of the Fisher-Z. The sample size is there. So in meta-analysis, we use these effect size as our outcome or our response variable in our meta-analysis models. And in meta-analysis, we conduct analyses similar to other applications of statistical analysis. And we typically ask two main questions. So whenever we're doing a statistical analysis, we usually ask, what's the average? And the same is true in meta-analysis. Our first question is usually, what is the average effect size across the studies? And how much does that effect size vary across the studies? We'll see in a minute that we're going to look at each of the studies that are examples, and we're going to talk about sort of what is the average effectiveness of the team training. What is the average correlation between characteristics of the network, of the team network, and the team effectiveness? And so that's the first main question. But often the second main question is the one that's more interesting, and that's what makes it meta-analysis exciting, for me at least. And that is to ask the question about what characteristics of studies are associated with variation in effect size across studies. So one way to think about that is we have a set of studies that probably vary from each other. They probably are not getting the same answer. And what meta-analysis can help us to understand is what characteristics of those studies might be related to that variation across the studies. So we can begin to understand what might be related to effectiveness of the intervention in different studies, what might be related to the correlation between the network structure of a team and its effectiveness. And so we're going to begin we're going to look in the next few slides about examples of these kinds of questions. So the only other thing I wanted to talk about is that meta-analysis differs a little bit from typical statistical analysis in that it uses weighted techniques. Recall that I showed you the standard errors of the effect size a few slides ago, and we noted for both of the effect sizes I just showed you, the standardized mean difference and the correlation, both of them had standard errors that depended on the sample size of the study. So the precision of that effect size depends on the sample size of the study. And so what meta-analysis does is uses weighted analysis. So all the statistical analyses we do in meta-analysis weights by the standard error of the effect size, because we believe that bigger studies have more precise estimates of that effect size that we're interested in. So let's look at some examples from our studies that we're looking at about average effect size. And so again, that first question we usually ask in a meta-analysis is, what's the average effect size across the studies? So in the Balkundi meta-analysis, one of the hypotheses Balkundi was interested in was the centrality of a team's formal leader in the informal social network. And the hypothesis is that the more central that team's leader is in that informal social network, the stronger the association with team task performance. In other words, the more central the team's formal leader is going to have a positive association, a positive correlation with the team task performance. Okay. And then in the Delise example, their overall hypothesis is that team training will have a positive effect, that team training will be effective on overall team performance. So let's look at the results that Balkundi did get. I'm sorry if this is a little small, but I've highlighted just that fourth hypothesis in the paper about the about the centrality of the team leader. And so what we have here in this line is the results for looking at the correlation between, or getting a mean correlation for the centrality of the team leader to the team performance. Okay. That's what we're looking at here. So there were 13 studies in that meta-analysis that had an estimate of team leader centrality and team performance. That represented 505 total people within all 13 of those studies. And we see here that they got a mean correlation of 0.25 and a confidence interval that ranged from a 95% confidence interval that ranged from 0.19 to 0.35. So we see that they're finding across those 13 studies, they did a weighted analysis and they get this mean correlation of 0.27 with this particular confidence interval. So we see that they are finding a positive relationship between the centrality of a team leader and their team performance. I just want to note here briefly, if those of you who are familiar with meta-analysis in business and management, that there's this estimated row here. There is a very long-standing tradition in the business and management to use methods of meta-analysis that were first discussed by John Hunter and Frank Schmidt. And in those meta-analyses, there are techniques for correcting our correlations for attenuation bias, for reliability, and so forth. So that's what this this particular column is, and I just wanted to point that out to those of you who are more familiar with meta-analyses in the business literature. Okay, so moving on to our other example, the DeLeese example, we can look at what they found for their question about the average effect, and we're just going to look here at the overall effect. So they found 41 studies, and in those 41 studies, there were 1,400 plus participants, and they got a D, which is a standardized mean difference of 0.85. So what this means is that on average, the experimental group was scoring 0.85 standard deviations above the control group in these 41 studies. But also note here that the confidence interval includes 0 and is a fairly wide range. Okay, so whenever we do statistical analysis, it's not enough, right, to just say, if my students came to me and said, here's the mean of my set of from my data, I'm just going to go home now. That's not enough, right? We need to understand not only what the mean is, but how much the effect size varies. And we want to understand if the studies are all agreeing about the effectiveness of an intervention or about the strength of that correlation among two constructs. And more formally, we call this examining the heterogeneity of the effect sizes across studies. And so I wanted to show you, I'm not going to go into all the different ways that we use to measure sort of that variability across studies, but I'm just going to show you 2 examples from 2 different studies. In the EGLE study, this is again that differences, sex-gender differences between men and women on transformational, transactional, and laissez-faire leadership. This was a table from that study, and one way to look at heterogeneity across studies is to calculate what's called a Q statistic, which they do here. And a Q statistic is based on a chi-square. And if it's significant, it means that there is a significant amount of between study variability in that particular meta-analysis. And we can see here, if we just look at that first line on transformational leadership, they had 44 studies. They're finding a standardized mean difference of -0.1. The negative means that men were scoring lower than women on transformational leadership measure. And we can see that there's a significant Q statistic. So that means that indicates that this might be the mean of those set of 44 studies, but there's a great deal of heterogeneity across the studies. The studies are not necessarily agreeing in how strong, how big that difference is between the 2 groups. And so that's one way we look at that heterogeneity across studies. A second way we do that is also by producing what we call forest plots. So here I want you just to focus on the middle part here in the blue box. This is a forest plot from a Campbell collaboration review that's looking at agricultural input subsidies for improving productivity, farm income, and other things. And so this is just 3 studies that look at the impact of agricultural input subsidies on farm incomes in Malawi, Zambia, and Nigeria. And what we see here, what this picture shows us is the individual effect sizes for 3 studies. And let's look at this middle study. The little, if you can see, there's a little diamond in the middle. That is the mean effect size for that study. And then the whiskers are the confidence interval for that study. And what's hard to see though is that the size of the diamond within each of those studies is related to the size of the study. So so this particular study has a littler diamond than this other study. This means that this is a study with um, a smaller sample size. And then this particular diamond shows us the mean of these three. But what we can see here is that this first study and this third study don't really overlap. So we expect that there's, this is indicating to us that there's a lot of heterogeneity. And we see over here, I know you can probably barely see this, but there's a thing called I-squared here. And that's another measure of how heterogeneous our effects are from each other. This value ranges from 0 to 100, and this is 97.1. So there is quite a bit of variation among the studies in their mean effect size. So once we find out, for example, in these two cases that we have a lot of heterogeneity, we often want, often the most interesting aspect then of the meta-analysis is to explore what might be related to all of that heterogeneity across studies. And so what are the potential aspects of studies, like participants, intervention components, settings, and study designs that are associated with effect size variation? And that's why I spent a little bit of time talking about coding, because we need to have, in the coding part of a systematic review, this is where we're going to think about what are some potential reasons why studies might vary from each other, and then maybe then we can kind of look at models of effect size to see if we can account for, or at least look at, what might be related to that variation. So one way to do that is to do subgroup analyses, which here's an example in the DeLeese, from the DeLeese study. And remember, one of the hypotheses in the DeLeese study was that military and civilian samples may have different effect sizes. So in other words, the effectiveness of team training may be different depending on whether the study used a military or a civilian sample. So what we have here is, if we just look at now at the overall effect size, we have 10 studies here that used a military sample. There were 270 participants in those 10 studies. And here we have an effect size of 1, which, by the way, in the social sciences is fairly large. It's a 1 standard deviation difference then between the group that got the team training and the group that didn't. And we can compare that to down here for the civilian samples. There were 31 studies there, 1,100 plus participants, and the effect size is a little bit lower, is 0.8. We can see for the overall civilian sample, that effect size is not different from 0 because their 95% confidence interval contains 0. But in the military sample, these team training programs were effective, and they were the treatment group was outperforming the control group in these studies. So this is one example of sort of exploring why the study, the effectiveness of team training might differ across studies. One possible explanation is that the kind of sample matters. Okay, and then in meta-analysis, we can also use techniques like regression, and we happen to give it a cute name. We call it meta-regression. So we can also use regression methods to look at the relationship between characteristics of studies and the magnitude of the effect size. So in the Bell-Cundy study, what we have here is, if we look here at familiarity again, if you recall, one of the hypotheses in the Bell-Cundy study was that how familiar a team was with each other might be related, might moderate that relationship between characteristics of the network, of the team network structure, and the team performance. This was just a simple meta-regression using familiarity among the teams as a predictor to predict that correlation between integrative network structure and team performance. And we find that the more familiar teams were with each other, the smaller the correlation between the integrative network structure characteristics and the team performance. Okay. So just to summarize this part, so we use meta-analysis models to examine the mean effect size and its variance across studies. And then we also use meta-analysis models to explain or explore how characteristics of studies might relate to variation in effect size across studies, where we are examining study heterogeneity. And that's often, a very important part of our of a meta-analysis. And briefly, you'll get these slides later, but how do we conduct meta-analysis? Well, there is a dedicated meta-analysis software called Comprehensive Meta-Analysis. It does cost money, but most of us who work in this area are using R. So if you were waiting for an opportunity to learn R, this is the opportunity. Most updated meta-analysis methods are available in R packages. I wanted to just briefly, I'm going to do this really quick because I only have about a minute left. A couple of innovations in meta-analysis methods. This whole time I've been sort of assuming that we only have one effect size per study. In fact, there are one of the more exciting innovations in meta-analysis in the past 10 years have been to develop models that help you analyze multiple effect sizes per study. Meta-analysis, the data we get in meta-analysis is inherently correlated because we have multiple effect sizes per study, and it's hierarchical. We have effect sizes nested in studies. There are a whole host of new models that we use now to take those things into account. Another important part that would be, I think, of use to people in business is methods for SEM models, so meta-SEM. There are a whole host of methods for estimating path models in meta-analysis, and this, again, would be taking that Belkundi study to another level and looking at that, actually estimating that path model that Belkundi had in an earlier slide. Briefly, we have all kinds of new methods for publication bias and selection modeling. I can share those methods if you are interested. And I also wanted to briefly note that there's been a big interest in these things called evidence and gap maps. This is using systematic review methods to create maps of the evidence that exist in the literature. So this is not really meta-analysis. This is really using scoping reviews to identify and map out studies. Here is a quick picture of an evidence and gap map. This is on performance measurement and management in primary care delivery systems. Each row is a different kind of intervention. Each column is an outcome. Where you see the gray dots, this is the number, the gray dots represent in size the number of studies that have been done, say on clinical practice guidelines and adherence to recommended practices. The colored dots are the number of systematic reviews. This gives us a visual picture of where the literature is and where we might need to have some more primary studies. And there is a link at the bottom here for looking at that particular map. So I will stop there. I hope I didn't go over too far, and I will stop sharing my screen, and we can take some questions.
Great, thank you, Terri, for a very informative overview of meta-analysis. We have quite a few questions. I will try to group them and hope to address as much as possible. The first question is about the number. What's the number of studies, minimum, maximum number of studies to be included in the meta-analysis?
So I have like a facetious answer, and then I have a real answer. So my facetious answer is that we always want to use, meta-analysis, even if we only have 2 studies, to look at the mean and the variation across those 2 studies, because we don't want to use our own cognitive algebra to decide if 2 effect sizes are different or not from each other. But the more serious question is that power, you can power for the mean effect size. We don't, we don't need that many studies. And in fact, power is not that bad for, even if we had 5 studies or 10 studies looking at the mean effect size and its variation, we can do that in small meta-analyses. Those analyses that I talked to you about, those meta-regression analyses, those analyses that look at heterogeneity, those need a few more studies. A typical systematic review or meta-analysis in education, that area I'm familiar with, would have, say, 20 studies, 20, 25 studies. We still do meta-regression there, but we run into power problems pretty fast. So those kinds of more exciting models really do need, the typical size for a regression, which would be 20 studies or so.
Great. Thank you. How can you include path analysis and t-values in meta-analysis?
So there are some emerging methods now that are actually looking at meta-analyzing path models. So if people use the same path model across a bunch of studies, there are methods in development to meta-analyze those actual full path models. But we can also use these meta-SEM methods to, in the first stage, get all the correlations that might be in a hypothesized path model that you have, even if they haven't been, even if that path model hasn't been estimated in every study. So you can imagine gathering all the correlations and synthesizing those correlations in a particular path model, and then you can use these meta-SEM techniques to calculate that path model. But if the second question is about t-statistics, we can transform t-statistics into different kinds of effect sizes. It's hard for me to answer that if it's not, I mean, I'm not sure if you're talking about if you are in a, you're in a study and you can't find the standardized mean difference, we can use a t-statistic and transfer that into a standardized mean difference.
Great, thank you. Can you comment on the use of Cohen's D and Hedges G? What are the threshold values of these indices? And
Okay.
should there be a default approach?
Okay, so got a couple things. Okay, so so I showed you Cohen's D, obviously, but Hedges G, and I also have to say that Larry Hedges was my advisor, so we have to put that out there. But Hedges G is Cohen's D corrected for small sample sizes. So there is a correction that we normally just apply all the time, because it doesn't, it only affects small it only affects the standardized mean difference from small studies, but they're essentially the same. We interpret them the same way. But if you're asking about how to interpret effect sizes, that is a very difficult thing. And if you're asking about whether we talk about small, medium, and large effect sizes, a lot of us spend a lot of time talking about how we think about small, medium, and large effects. And what we normally go back to is that it really depends on the context. So that you need to think about sort of translating those effect sizes back to a metric that makes sense to you. And then talking about whether they're small, medium, or large. Way back, Cohen talked about 0.2, 0.5, and 0.8. And I think we've gotten stuck in that because there are contexts where even a little bit of change, could make a big difference in people's lives. So.
Great. There are a couple questions about moderators. This person was confused about testing moderators in meta-analysis. Seems complex. Like, again, how many moderators can be included in one study? And does that mean And sometimes I guess some people can be confused between control variable and moderator.
Oh, right. Okay. So I admit that I'm very loose about my moderating language, what I call moderators. Um, but what we normally say is that there are a couple of key, let's say, explanatory variables in a meta-analysis that have over and over again proved to be important. One of them being, if we're looking at standardized mean differences and intervention effects, one of those is study design. Over and over and over again, we see differences between randomized controlled trials and quasi-experiments. And so a lot of times we advise, that one moderator that has to be in your meta-analysis model is to try to account for study quality. Okay. And then other, and so that might be one of those sort of control variables that we always have in. And then we might have other variables that are related to hypotheses or theories we might have in a given topic. And again, I mean, as much as I love, that is an important part of meta-analysis. Again, we do run into sample problems, small sample problems. So if we, with only 20, say, studies, we're not going to be able to do these massive, meta regressions. But we can test and explore at least, and not over interpret the results from some of those models. I hope that helped a little bit. Yeah.
Mhm. Here's another related to moderators is that the same outcome measures could be different, even they're labeled the same, but they were measured differently. Could the measurement type be moderators?
Absolutely. That is another one of those cases where we often see that how something was measured is related to the size of the effect size. And so that if that's one of your hypotheses, then you definitely want to put that into your model. You want to explore that. Yeah.
Mhm. Um, when would you use subgroup analysis versus meta regression and why?
So I would, like in any statistical analysis, I would rather use a more multivariate technique, because one of the problems in meta-analysis and in systematic review is that all of these characteristics of studies are confounded with each other. So if you can, you want to use multivariate methods like meta-regression so that we can account for some of that, some of that confounding. But if we're in a small sample space where we don't have that many studies, then looking and exploring subgroup analyses might be at least give you some insight into what might be reasons why the effect sizes are varying. um, but again, if you do a whole series of subgroup analyses with only one variable, we don't we then we're going to run into that problem of not understanding how those variables relate to one another. So I'd
So
say, yeah, go ahead.
yeah, I guess the follow up for that is it typical to test statistical differences between overall means when you have subgroup.
Yes, it is. It is. And the examples I showed you didn't have those tests, but there are tests for looking at those. And more formally, the statistical difference between the two.
Can you use Schmidt and Hunters to come out with mean correlations and then use R to calculate meta regression?
Yes, yes. Yes, you can. So, so I realized that I did, sort of kind of glossed over that, but definitely the whole tradition of Hunter and Schmidt's meta-analysis tradition is to be really concerned about, the measurement aspects of the measures we're using. And so definitely getting the correlations and getting them after you've corrected them for the different biases like attenuation bias and measurement bias, reliability, and so forth, then you can definitely use those correlations in meta regression, in a meta SEM, whatever. Yeah.
Yeah. And the tools for meta SEM is Amos, I guess R can still can handle that, and maybe Amos, or what else do you recommend?
So Mike Chung has a program called Meta SEM. And he also has a book on these techniques. And then Susanna Jack, J-A-K, has an online book, which I can put in the references for you that show you how to use our program Meta SEM.
Great. There's a question in the chat. What's your view about meta-analysis in relation to qualitative methods?
So there is a whole, I am a quantitative researcher, but there is a whole field of methods for synthesizing qualitative results from studies. And I can provide a whole bunch of references for that. This has been developing mostly in the medical literature, but I'm happy to share those resources with you. I've been gathering them up because I know this is a big area of interest for people.
Okay, great. Thank you so much, Terri, for a very informative session. And thank you everyone for coming and the interesting questions.